Next up, we have Benjamin Heinemann. He is a senior grad student in the AMP lab, working with Jan Stojka.
Senior, that's the nice way to put it.
And he's also leading the development effort as an engineer at Twitter in the Mesos project. So take it over, Ben.
Thanks. All right. Hi, everybody. I'm going to talk about a project that started here at Berkeley. It's called Apache Mesos. It's actually a project that's in the Apache incubator. It's been in the incubator for more than a year now. The project actually, as I mentioned, it's started here at Berkeley as a research project between myself, Andy, Matej, Ali Gotzi is a postdoc, Jan Stojka, Scott Schenker, Brandy Katz, and Anthony Joseph. So you can read more about the research origins of this project by following this link. I'm actually not going to talk as much about some of the really low-level technical details about Mesos. This is a bit more sort of an overview and sort of some hands-on things about how certain things run on Mesos, like Hadoop. And then a few little bits about stuff at Twitter at the end. Okay, so the motivation for the project was really that a lot of people are looking at their data centers and they're deciding how to allocate resources to their services and their frameworks via static partitioning. So they're saying, okay, we're going to run this Hadoop cluster and give it so many nodes. We're going to run this analytics thing and give it so many nodes. We're going to run this web service and give it so many nodes, so forth and so on. So just so I get the terminology, so everyone's on the same page, when I refer to things that are services or frameworks, I'm really referring to sort of this Venn diagram of stuff. By services, I mean any request response like system you might build, maybe out of Rails, maybe Node.js, using Netty or Jetty, or pick whatever server stack, networking stack library of your choice. And on the other side, on the frameworks, I'm really talking about analytics things. So these are Hadoop, MPI, Spark, Storm. And this is really a Venn diagram because there's some intersection here. A lot of the real-time frameworks end up looking a bit more like request response, even though they're kind of doing analytics-like jobs. So that's what I mean when I refer to these things. I'll be pretty concrete, though, and I'll just use Spark in places, so it's more concrete. So motivation was static partitioning, and really we decided that static partitioning was not a good idea. So why not do static partitioning? Well, there's a couple reasons. One, it's really hard to fully utilize machines. Machines that are purchased at Twitter are at least 24 cores, sometimes more, and the amount of RAM is in the 50 gigabytes and above. It's hard for a single service to utilize a single machine in this way. Even if a single service can utilize a machine in this way, it's not clear that that's a good idea for fault tolerance reasons. Okay, it's harder to deal with failures when you statically partition your clusters. This obviously follows from the fact that you have to heavily over-partition each of your, sorry, you have to, you have to allocate each partition. So in the event of lost nodes, you have enough resources to continue to run your services. And the last one I'm going to mention here is that it's really hard to scale elastically. So if you have a single service which can actually take advantage of slack resources or idle resources not being used by some other partition, it's really hard to do it. There's a bunch of other reasons why static partitioning is not a great idea. For this audience, I think one that will really ring true is the fact that you share a lot of data amongst a bunch of different services, and if that data is living in something like HDFS, you'd prefer not to replicate that data between multiple different HDFSs. You prefer to have one HDFS that all the services can run over. Okay, so we built Mesos. So what is Mesos? Well, in instead of running these services and frameworks directly on the nodes themselves, we run them on our platform instead. So like all problems in computer science, we solved this issue with a level of indirection. That's what Mesos is. So it's really trying to be two things. The first thing is it's trying to efficiently share the data center resources. So that means getting better utilization. These are these three issues I mentioned before. On a single node, that means running jobs from multiple services at the same time, Hadoop, multiple Hadoop, Spark, MPI, so forth. Dealing with failures, when one machine fails, we can reallocate resources to higher priority jobs, dynamically, programmatically, without any human intervention. And of course, we can do things elastically. So as a service doesn't need any resources because it's the middle of the night and not many people are tweeting, we can scale things like Spark up to actually use those resources. Okay. And the other thing that we tried to accomplish with Mesos was to make it easier to build these distributed services and these analytics frameworks, so that people could sit down and they could use things like Hadoop and Spark and Storm, but they could also, if they want to, build a new one themselves. So in that sense, we kind of think of it as kind of like a kernel for the data center. It's a pretty low-level interface to build these things, and lots of other users can use the stuff on top. And in particular, it provides a bunch of primitives that can be used for actually building these systems. So these include messaging, mechanisms for high availability, fault detection when things fail in your cluster, resource isolation, which I'm going to talk a bit about, resource monitoring. There's a bunch of other ones. This is just kind of like a quick overview. Okay, so a framework that runs on top of Mesos is really built out of one or two parts. The first part is something that we call a scheduler. So what a scheduler is, it's a piece of software that communicates with the Mesos master. In particular, it requests resources from the Mesos master, and given any resources that have been allocated to it, it assigns tasks to run in the cluster using those resources. So to be really concrete here, if you're running multiple frameworks like Spark and Hadoop on the same Mesos cluster, you have a Hadoop scheduler and you have a Spark scheduler, which is communicating with Mesos. So in the presence of multiple schedulers, we actually need to decide how to allocate resources across those different schedulers. And that's done by Mesos itself in something called the allocation module. So really what this is it's two-level scheduling. So at the first level, the platform is controlling resource allocations to the schedulers, and the schedulers are given whatever resources have been allocated to it. They're deciding what tasks they want to run using those resources. Okay, so the way this kind of ends up looking, as you can imagine, that a job has been submitted to Spark. For example, on your command line, you go to run something, you want to run some tasks, you can make some requests for resources. The master will decide what resources it can allocate to you. It allocates those resources in something we call an offer of resources. Given those resources, Spark then constructs tasks to run. Okay, so what's a task? So a task in our system it's just an abstraction that represents some consumption of resources, some consumption of CPU or RAM or disk or whatever resources that have been configured in the cluster. So I mentioned tasks because it's really important to understand that tasks are first class in Mesos, but there's no real requirement on how they're constructed actually in the cluster. A task can be a thread inside a process. A task can be a work queue. It's just an abstraction. But by making tasks first grain in Mesos, it enables us to do fine-grained resource sharing. And I'm going to talk a little bit later about resource isolation, and hopefully this will become more clear then. Okay. So this abstraction of a task gets sent by Spark to the Mesos slave. The Mesos slave is actually responsible then for launching the task, for isolating it, for watching it to make sure that if it fails, it tells Spark about the fact that it failed, and so forth. Okay, so as I mentioned, a framework is really kind of consists of two parts, the scheduler, and then the second part, which is optional, and it's what we call the executor. So note that the executor, just like task, is also a consumer of resources, and you'll see why in just a second. So why the executor? Well, sometimes it's the case that you don't just, the task you want to run isn't just like some command line that can be launched, but it has some other semantics, and the way you want to run it, you really will want to control how that task runs. Again, perhaps this task is just a thread that's running inside some other process that's long-lived. So that other process would be the executor. So in this case, if a task uses an executor, Mesos makes sure that an executor has already been launched for that framework. The task is still sent directly to the executor. And again, the platform is responsible for isolating the executor and any tasks that run underneath it. Okay, so again, on a single slave, we might be running executors from multiple frameworks from both Hadoop and Spark at the same time. So this asks the question, well, how do you do the isolation, the performance isolation across these different things? Okay, so the project started out doing resource isolation using Solaris zones and Solaris projects, but nobody wanted to use Solaris. So for those people in the audience that actually asked a question about Solaris, there is a bunch of rotten code in the repository that does isolation for Solaris, but what's supported now in Mesos is for Linux. There's some history about that as well. We actually started with using Linux kernel containers, and we moved directly to using control groups recently. But this enables us to isolate CPU, memory, disk I/O, network I/O, and more things in the future as we go. There's a question, yes?
Oh yeah, I just wanted to say, I think I just built Trunk on OpenJDK stuff. So you moved to Linux, you got away from Solaris. By the way, you can also move away from Sun Java and go to OpenJDK.
Oh, fantastic. Great, thank you. Awesome. Okay. So back to resource isolation being fine-grained. So we actually use a control group per executor or a control group per task if the task doesn't actually have an executor. So this is a really important point. It actually allows us to adjust resource limits dynamically. So over the lifetime of an executor, we can change the amount of resources that have been allocated to that executor on a single machine as tasks come and go. So rather than fixing the amount of resources that we allocate at the beginning and assuming that those resources can't be used at any other time, we can adjust those resources over the lifetime. So why is this interesting? Well, probably one of the biggest things that's interesting about this is it's one of our biggest differentiators from Hadoop Yarn, which is following a very similar model of Mesos. Okay, so I thought since this is a higher level talk, it would make sense to kind of jump into understanding how some of the frameworks actually run on Mesos. And some of this is pretty hands-on. I mean, I'm not expecting you to run some commands that I'm going to mention, but I am hoping that these slides can be useful when you leave here if you actually wanted to run Hadoop on Mesos or any other things on Mesos as kind of like a guiding point of things you want to do. Okay, so in the Hadoop world, again, when I was describing a framework, it really consists of two parts, the scheduler and the executor, and that maps really cleanly to a job tracker and a task tracker, okay? So this is kind of what it looks like. You have the job tracker, which communicates with the Mesos master, and on the Mesos slave, you actually launch the task trackers as the executor, and you run your maps and reduces under that. Of course, it can't just be that simple. We need a little bit of shim in between the job tracker and the task tracker to actually speak Mesos, to actually communicate with the Mesos layer. So to actually get this to work, we need to do a minor patch and also contribute a Hadoop scheduler. Okay, so what's this look like? Well, if you were to try and run Hadoop on Mesos today, your first step would be to go grab the jar. You grab the jar, you'd unarchive it, and you'd have Hadoop. Okay, and you could either grab 2205 or you could grab CDH3. Okay, at that point, you apply this minor patch, which enables us to build a contrib scheduler that doesn't actually have to touch any of Hadoop itself. So this patch, again, for CDH3 or 2205, it's actually quite small. It's about, well, here's the diff stats. So it's a pretty small patch, and this patch has also been committed in Hadoop trunk at these revisions. So if you're running a version of Hadoop that's after these, then you don't actually even need to apply this patch, okay? So this patch is very generic. This patch has absolutely nothing to do with Mesos. It just adds some functionality to Hadoop to make integrating it with Mesos much more easier, or integrating with anything for that matter, integrating it with something like Yarn or any other resource manager. Okay, once you've applied the patch, then you can copy over the source files, which are the Mesos specific scheduling logic, which communicates with Mesos, which also has some specific code for communicating with the Mesos slave on the executor side. Okay, so what does that look like? Well, if we're in Hadoop, we've already copied this stuff over to contrib Mesos. These are the source files. There's really not that many of them. The total line count is about 1,000 lines. So the code to make Mesos run, to make Hadoop run on Mesos is quite small. It's 1,000 lines of code that could be included as a jar, and it's about 70 lines of code that's a patch that's already been committed. So we're not going in and dramatically changing Hadoop to make it run on Mesos. It's pretty minor. Okay, there's actually a tutorial shell script that you can run if in your build directory you jump into, wait, let me go to the top here. So I'm in my build directory and I'm in Hadoop. I can actually run a tutorial. I can. Is that good enough? Is that good? Okay. And at this point, you can actually just, you can actually just make Hadoop, and it goes through all the motions. It actually runs the tutorial without waiting to ask your question, but usually it waits to ask your question. And it takes you through all those steps that I just mentioned about applying the patches, copying over the directories, building Hadoop. And in fact, it starts by pulling Hadoop down from one of the Apache mirrors. And you can do the same thing for, I did this for 2205. You can do the same thing for CDH3. Okay, so this takes a little while. The tutorial will actually, again, like I said, it will build all of Hadoop, it'll connect it all, and at the very end, it'll even run word count on Mesos. You can run Mesos in a local cluster on your box, and it launches the local cluster, and it runs word count. So if you're interested in playing around with Hadoop on Mesos, you don't need to set up a cluster. You can just do it right from your laptop. You can figure out how Hadoop works. You can just go from there. Okay. Getting back to this. Okay, so another framework is the MPI. So I mentioned this one because it's actually being used by a fair number of people, and it's got some differences from Hadoop. So the MPI scheduler that interfaces with Mesos is actually written in Python, and it wraps the standard MPI exec that you would use for launching MPI. The MPI executor the MPI framework does not actually use an executor. So as I mentioned, a framework can be built out of a scheduler and executor, or just a scheduler and launch tasks. The MPI one's actually a very small shell script, which just launches tasks. It's also included if you check out the distribution. The one crux here is you have to make sure that MPD is actually on all of your machines. But if it is, that's pretty simple. You can just run this command, have it connect to a Mesos master, and it launches your MPI jobs. Okay. So at the point that we started working with the guys over at Twitter, we really just had Spark, Hadoop, and MPI running on this system. But since we've been there, we've done two things at Twitter. The first thing is we actually got Storm running on Mesos. So you guys have probably heard about Storm from a few different people over the course of the past couple of days. It's a real-time-like streaming framework. We also built a framework directly on Mesos that doesn't really have a name, but we just kind of called it the Twitter framework, so I attached the Twitter bird there. But I'm going to talk a little bit about that. So what is the Twitter framework? Well, it's a framework that makes it easy to deploy and manage production servers. So you can imagine that somebody's hired into Twitter and they want to build some new service, and this service is perhaps just a request response service. Who knows what it does, but they just want to deploy it somewhere in their cluster. They don't want to get allocated some fixed number of machines. So they'd like to just run it someplace. So they built this Twitter framework, which does exactly that. So you submit these jobs or these servers via configuration file. It communicates with the system to actually get resources allocated to it, and then it launches those services. Okay, so it's got a bunch of other features. In particular, it can provide restarts and updates of your services. It relaunches the processes, of course, after failures, and it does a bunch of other things. I'm going to talk a little bit more about that when I show sort of how that runs at Twitter. Twitter's very serious about using this system. They want to use it very much like the kernel for their data center, building on top of this framework that I just mentioned, running their analytics on top of it, having a single platform in which they run all these things on top of. The cluster right now, this actually is about 2 weeks ago, was at about 1,200 nodes, and it's probably closer to 1,400 or 1,500 now. It's growing very, very rapidly. They monitor the resource utilization on those machines versus the machines that have been statically partitioned in the cluster very closely. The minute that number drops below between 5 and 10%, they'll probably get mad at us, but right now it's looking good, and we hope to increase that utilization over time as well. Okay, so what I wanted to do quickly was actually just give a little demonstration. Okay, perfect timing. So the tutorial finished. This tells you all the steps that the tutorial actually ran, and it actually did run the word count job on Mesos after it went through and applied all the patches and did all the stuff. Okay, so what I wanted to do next was, let me just, okay. I wanted to give a quick demo of what Mesos looks like at Twitter. So, okay, so this is one of the clusters at Twitter. It's, I guess, a medium-sized cluster. I think there's maybe around 600 nodes in this cluster or so. In particular, what's interesting about this cluster is that it's actually running some pretty important jobs. So these are a couple of the ones I want to call out. These are the ads servers. So again, these are services that were launched through that framework that I mentioned that Twitter built on top of Mesos. So ad servers, these are the servers that are actually deciding what ads to show in your tweet stream. These are very serious. This is what makes the company money. When the service goes down and ads goes down, money is lost. So this is pretty serious. Another one that I like in here is type ahead. For those of you that recently have had type ahead turned on for you in Twitter, this is when you start typing a search and it actually shows you a bunch of things that you might want to click on. All the type ahead services are also running through the Twitter framework on Mesos. And there's a bunch of other ones. So what I'm actually going to do for the demo is sort of, I suppose, a little black magic. I'm actually going to SSH into this box and kill this master and see that indeed another master comes up. Okay, so I'm in this.
Are you sure about that?
So I've connected to this box. You can see that there is in fact the Mesos master running. We use Monet to launch the masters. Okay, so I just restarted. So yep, this web page just telling me that it failed to connect because it had just died. It said started as just now. Well, actually, thanks to Zookeeper, it gets started a couple times. Or sorry, to Monet, it gets started a couple times. So master is not currently leading, but another master actually gets elected, which is good. And nicely, it takes us over to the other master. And this is another box. One less task is running. But the good news is, hopefully the good news is all the ad servers are still running. So. At least this one is running. Okay. So, one of the things that we've spent a lot of time at Twitter doing is trying to make the reliability and the robustness of the system be great. Instead of spending more time doing other things that I wish we could have spent time doing. But that being said, I get to give a demo like that and feel really confident about just killing master machines in the cluster running ads for Twitter. Okay, so I got a few, yes?
That web UI looks a lot nicer than the ones that everybody who did exercises yesterday was using. I just wanted to say that Twitter has been advancing Mesos at a very rapid rate, and the combination, so we on the Spark side, or Matei's team, has been working hard to continue porting to the updates that Twitter's pushing. So you can see that even within the last few months since the version you were using on the AMI yesterday, web UI has gotten much, much more awesome.
Yeah, so Twitter doesn't do any development in the private. All development on Mesos is in the public. So if you used Trunk from SVN, you'll be using exactly what's running in Twitter's production clusters. Pretty much everything that gets committed gets immediately deployed to a cluster at Twitter. We have like sort of a bunch of clusters, and we stage all our code through them. So if there is a bug, it'll also get fixed pretty quick. Okay, so just the last couple of minutes before I send you guys off to lunch, a few details. So Mesos is actually written in C++. It's about 50,000 lines now, and growing at a fairly steady clip. It uses a C++ library for actually doing all of its networking, network communication, all that stuff. That's another open source project. You can check it out. There's APIs to interface with Mesos in C++, Java, and Python. So Spark obviously Spark and Hadoop use the Java APIs. Python is used by MPI, as I mentioned. That's one of the reasons I mentioned it. And it uses protocol buffers for its data transport. So from day one, you can do rolling upgrades of of Mesos, and I'll mention that in just a sec. We're doing a lot of stuff in the future related to resource monitoring collection, smarter allocators, hierarchical allocators for users and frameworks, resource revocation, better scheduler management. There's a bunch of things. It's an open source project. Please, by all means, dive in and contribute. You can try it out. You guys have already tried it out since you ran Spark stuff. But you can run it on virtual machines. You can run it on your private data center. One of the nice things about running on virtual machines is that if you ever do decide to move to a private data center, you don't need to change how you run it in your private data center. Your code just keeps running on Mesos, and you just have to deploy Mesos in the private data center. So operating, since this is, again, supposed to be a bit hands-on, the only real requirements when it comes to operations of Mesos right now is Zookeeper. That's for now. We're actually going to hopefully eliminate that, so it's even easier to operate in the future. But you do still need to manage deploying the Mesos binaries yourselves, the Mesos slaves, to all the machines. You can use Puppet or Monitor, whatever you want for that. Turns out deploying Mesos is a pretty static operation, so that's fine. And if you're operating, you can do rolling up upgrades today. So if you start running it and you end up, there's some patch which gets contributed to Trunk. You can build that new version, and you can do a rolling upgrade of all your masters and your slave because it uses protobufs. You don't need to worry about having to bring the entire thing down and bringing it back up. Obviously, Twitter has not once they've not brought the Mesos cluster down in upwards of about a year and a half now. So every single upgrade has to be rolling, and we take that very, very seriously. In the future, though, we plan to make it such that when we do upgrades, we don't kill executors and tasks. Okay, I'll take questions a minute late. Go start in the back. He had his hand up first.
You say Mesos has an API. What would you do with it other? Oh, sorry. Hi. When you say Mesos has an API, what would you do with it other than deploy it, start it, and stop it? Do you talk to it to do other things?
Well, when you're lonely, you talk to it. No, there's really just a small number of primitives that you use as an API. Those things are determining, getting an idea of what resources are available in the cluster, making requests for possible resources, launching tasks, finding out when those tasks have been lost because the machine died or gone failed because for whatever reason their exit code was not 0. There's some other things for high availability. There's some mechanisms built into Mesos so you can store state, so you can just store distributed reliable state. So if your framework scheduler actually fails, when it comes up, you can get that state back. And that's the kind of stuff that we're constantly modifying and changing. The goal is not to make Mesos be some giant, huge layer. The goal is to make Mesos be a pretty simple, thin, kernel-like layer that really gives you some of these abstractions that you would need to launch your tasks, to store some information, basic information. The right way to think about it is imagine, we would like to get it to the point where you can imagine sitting down and having some API that you can write a distributed application against and assume that when you go from cluster to cluster, you have that API, kind of like POSIX, kind of like glibc, whatever abstraction you have for doing that. Creating threads, allocating memory. These are the types of things that we don't really want to go beyond that. We just want to provide that kind of stuff, the analog, of course.
Hey, I was just wondering if you have any thoughts on just kind of the emergence of virtualization over the last 10 years and how a lot of institutions have been moving to isolating their services and frameworks through kind of a private cloud model or by taking advantage of more advanced virtualization software.
Yeah.
Do you see one day all kinds of frameworks and applications integrating with a layer like Mesos and maybe stepping away from the private cloud virtualization model?
So it's a good question. So I'll say a few things about that topic. The first is that there's no reason why our slaves today can't launch virtual machines. So right now we use control groups. There's no reason why we couldn't actually just launch a virtual machine, use KVM, or anything else. So in fact, there's an open patch for adding something that does exactly that actually launches virtual machines. At a place like Twitter, and I imagine many other places as well, there's another problem which I call VM sprawl, which is when you use the virtual, so virtual machines provide isolation in some ways, but isolation is almost provided as well by things like the operating system itself, kernel containers, other things. But the other thing that virtual machines provide that is really valuable is sort of your bundled environment. You have the version of Python you want to launch your task. You have whatever else you need. And that's a really powerful piece of virtualization, but a lot of companies are afraid of the ability for people to shoot themselves in the foot when they have that much power. So you can imagine at a place like Twitter when that one cluster I showed was running 600 tasks, it would be an absolute nightmare if those were 600 different virtual machines that all had slightly different versions of glibc or slightly different versions of Python or whatever else. When it comes to operations, it becomes a total nightmare when a bug is introduced, say, in JDK7 or anything else, and you need to go upgrade all those things to be able to control all these people's virtual machines and upgrade them appropriately, deal with the management of that. So I see a lot of companies, from a management perspective, more interested in single system images and well-known packages being installed or shipped to boxes where they're needed. So in Twitter's case, When we're doing the actual allocation of resources, we can include information about what packages have already been installed on the machine, and if not, they use a system called Murder to get the packages on those machines. Murder is basically BitTorrent. So you can imagine when you go to launch your task, if your task doesn't have the version of Python 2.6 that you need, it gets BitTorrented to the box, and then your task starts running. Now, there's lots of interesting questions there, performance questions. What's faster, BitTorrenting Python 2.6 to the box, or copying the entire virtual machine image which already has Python 2.6 in it to the box? It's not clear that there's any wins in those trade-offs, but the management win is really huge, and so that's the perspective they've taken. So, yeah, I mean, what it doesn't answer is you can't run Windows and Mac and Linux and Solaris on the same box without virtualization, but for most people's jobs that they're running, they've got a single system image, and that's just the way they run it. And that's, yeah. I'll take one more, and then.
So would the deployment scenario be that you deploy Mesos on bare metal directly and run off those machines, or would there be a viable scenario where you run Mesos in a VM and you use something like OpenStack to slide around your VMs on your machines?
Yeah, so I think actually running it on a VM is a perfectly reasonable thing to do. The main reason I think is because we hope to be able to do smarter allocations of resources across the frameworks because we have this more intimate relationship with the frameworks. We have that API where we're communicating with the frameworks, they're making requests, we're giving them offers, and that's all done programmatically versus a lot of the other virtual machine-based things like OpenStack, at least that I know of, that are doing it a bit more in a configuration-based way, or a human comes in and might change the number of VMs that are assigned to things. In the Mesos world, it's all done much more programmatically. That being said, that's all I'll say.
Yeah, and we like all of the exercises we did yesterday were on EC2, and that's Mesos on top of EC2, which is obviously virtual machines.
Yeah. Does it play nicely with OpenStack? Never tried it with OpenStack. Never tried it. But as Andy says, we run it on EC2 all the time. And
if you try it, let us know.
And it works great on EC2. And one of the things that I like about running on EC2 is you can try things out, you can run things there, and if you decide to then actually move to bare metal, you just install Mesos and you keep running the stuff that you were already running. So it's another level of indirection that gives you that flexibility to move.
All right, thanks, Ben.
Okay.